Welcome to our course, Engineering Mechanics, particularly Statics of Rigid Bodies. Let's solve. First problem. Two forces are applied as shown to a hook support. Knowing that the magnitude of P is 35 newtons, determine by trigonometry the required angle alpha if the resultant R of the two forces applied to the support is to be horizontal. And then the other one is the corresponding magnitude of R. For this problem, we need to get the value of alpha so that the resultant R is horizontal. We'll also get its magnitude. Here in our problem, the way we solve this is by trigonometry. We'll do the tip-to-tail method or head-to-tail method. So the 50 Newton force is 25 degrees from horizontal, clockwise as in the figure. Let's connect the 35 Newton force in angle alpha from the horizontal, counterclockwise. Then we attach the tail of the first force or vector to the tip or the head of the last force or vector to get the resultant R. Because they are alternate angles, the alpha and the 25 degrees, they have the same values. So ρ, which is the opposite angle of the resultant. So let's solve. So determine by trigonometry. So let's solve using this. So Law of Sines. Now what I did here is, so force over sine of the opposite angle is equal to the force over sine of the opposite angle of the other. So first we need to find the value of alpha and the magnitude of the resultant R. And we also need ρ because we need this value based on Law of Sines. So to get the value of R. So let's take the value of angle alpha first. So let's use this relationship. So 35 over sine 25 degrees, which is equal to 50 over sine alpha. So multiply both sides by sine alpha and sine 25 degrees. So 35 sine alpha is equal to 50 sine 25 degrees. So therefore, arc sine of 50 sine 25 degrees over 35. So arc sine 50 sine 25 degrees over 35. Therefore, value of alpha, I'm going to store it at A, so 37.1382 and so on degrees. Next is ρ. So for the value of angle ρ, 180 minus alpha plus 25 degrees. So the summation or the sum of the angles of the interior angles of the triangle is should be equal to 180 degrees. Therefore, alpha plus ρ plus 25 degrees is 180 degrees. So ρ is equal to 180 minus alpha plus 25 degrees. So 180 minus, stored at A, alpha plus 25 degrees. So therefore, angle ρ is equal to 117.8617 and so on degrees. So for resultant R, this is the relationship. So 35 over sine 25 degrees, which is equal to R, the magnitude of the resultant R, over sine ρ. So multiply both sides by sine 25 degrees and sine ρ. So 35 sine ρ is equal to R sine 25 degrees. 35 sine ρ, which is stored at B, over sine 25 degrees. So therefore, the magnitude of the resultant R is equal to 73.2167 and so on newtons. So our answers are for the required angle A, so that the resultant of the two forces is horizontal. So 37.1382 and so on degrees, and the magnitude of the resultant R is 73.2167 and so on newtons. So next problem. So a steel tank is to be positioned in an excavation. Knowing that alpha or angle alpha is 20 degrees, determined by trigonometry, first, the required magnitude of the force P if the resultant R of the two forces applied at A is to be vertical, and then the corresponding magnitude of the resultant R. So on the first problem, we need angle alpha to get a resultant which is horizontal, Now we get the force P. We need force P so that the resultant of the forces applied is vertical. So let's do it again with the tip to tail method. What is needed is the resultant R to be vertical, the magnitude of force P. First force, so 425 at an angle 30 degrees from the horizontal. Let's connect angle or force P at an angle 20 degrees from the horizontal. So we'll need the value for the magnitude of the resultant R, which is vertical. So because of alternate angles, so there's the 30 degrees. And then let's just denote angle beta, which is the opposite angle for the given 425 pounds. And then angle rho for the angle opposite force P. We could also use the law of sines here. So 425 over sine of its opposite angle, beta, which is equal to P over sine of its opposite angle, rho, equal to R over the sine of its opposite angle, alpha, which is 20 degrees plus 30 degrees. So alpha is 20 degrees, rho. So we know that the resultant R should be vertical. So therefore, it's perpendicular with the x-axis. So 90 degrees minus 30 degrees is the value for rho. So rho is equal to 60 degrees. And for beta, the sum of the interior angles of the triangle is 180 degrees. So alpha plus 30 plus rho is and then plus beta is equal to 180 degrees. So therefore, beta is equal to 180 degrees minus alpha plus 30 plus rho. So therefore, 180 minus 20 plus 30 plus 60, 20 plus 30 plus 60 is 110. So 180 minus 110 is 70 degrees. So first, we get the value for P because we have the value for rho. So 425 sine rho is equal to P sine beta. We just multiplied sine beta and sine P to the equation. So divide both sides by sine beta, which is 70 degrees. So 425 sine 60 over sine 70. So 425 sine 60 over sine 70 degrees. So therefore, value for the magnitude of the force P, so that the resultant is vertical. So let's just store it at A. So 391.6821 pounds. And then for the value for the resultant or the magnitude of the resultant to R. So this relationship, law of sine. So 425 over sine beta, which is equal to R over sine alpha plus 30. So multiply both sides by sine alpha plus 30 and sine B or sine beta. And then divide both sides by sine beta, which is sine 70. So 425 sine 20 plus 30 is 50 over sine 70 degrees. So therefore, the magnitude of the resultant R is 346.4631 pounds. So here are our answers. So the required magnitude for the force P, so that the resultant is vertical, is 391.6821 pounds, and for the magnitude of the resultant R is 346.4631 and so on pounds. Next problem. Two forces P and Q are applied to the lid of a storage bin as shown. Knowing that P is 48 newtons and Q is 68 newtons, determine by trigonometry the magnitude and direction of the resultant of two forces. So force P and then head-tail method because we'll answer it by trigonometry. Given two forces and the resultant, so trigonometry. And then let's connect R. And then I just denote theta P as the angle measured from the horizontal, so theta P. And then theta Q is the angle of the force Q measured from the horizontal, and then theta R the angle measured from the horizontal of the force or the resultant R. We don't know yet if theta R is an acute or obtuse angle or less than or greater than 90 degrees. So we just assume it's an angle measured from the horizontal. Then theta p is for alternate angles. The equation for theta p, theta q, and theta r. So I just denote here angle p. So angle p is the angle opposite of force p. Angle q is the angle opposite of force q, and angle r is the angle opposite of the resultant r. So we can use the law of cosines here. So r squared is equal to p squared plus q squared minus 2pq cosine of the opposite angle of the resultant r. So you have p is equal to 48, q is equal to 60, and then r is equal to theta p plus theta q. Theta p we can get from the figure, so 180 degrees. So minus 85 plus 25 degrees, 180 degrees for the straight line. So our total there will be 180 degrees. So minus 85. So from the figure, 85 plus 25 degrees. Therefore, theta p is equal to 70 degrees. Next is theta q, which is equal to, from the figure, 25 plus 55 degrees. Therefore, theta q is equal to 80 degrees. Then r is equal to theta p, which is 70 degrees, plus theta q, which is 80 degrees. Therefore, r is equal to 150 degrees. So I think we have all we need. So we just substitute 48, 60, and 150 degrees to the equation to get r. So therefore, square root of 48 squared plus 60 squared minus 2 times 48 times 60 cosine 150 degrees. So therefore, r is equal to, or the magnitude of the resultant, just store it to A, so 104.3662 and so on newtons. So for the direction, we have theta r. So in choosing for the direction, we must have an answer which is less than 90 degrees. So theta r is equal to 180 minus theta p plus q. Theta p we have solved it earlier, so 70 degrees. And then for q, we can use the law of sine. So q over sine angle q, which is equal to r over sine angle r. Multiply both sides by sine q and sine r and just switch this position. So q is equal to arc sine, or angle q is equal to arc sine of q sine angle r over r. So substitute the given and the value for r. So arc sine 60. So sine 150 over the value for r, our resultant r. Therefore, angle q is 16.7053. Store it at b. So 7053 and so on degrees. So substitute it to the equation. So theta r is equal to 180 minus 70 plus 16.7053. So store at b. So 93, but it's greater than 90. So 180 minus that value. So 86.7053 degrees and so on degrees. So therefore, our answers are: the magnitude of the resultant of the two forces is 104.3662 and so on newtons, and its direction is 86.7053. So measured counterclockwise.